All right, Algebra 2, we are jumping into our lessons this week. So we're starting at lesson 68. And 68 talks about a scientific calculator, or for those of you guys who have a graphing calculator. If you don't, a lot of phones now have an app you can download, so I would encourage you to do that. Your computer has a free website you can go to for scientific calculators as well. So it's also talking about scientific notation. Don't forget that scientific notation is a way to write really large or really, really small, where it'd be like a decimal point 0.00000045 or something like that. So scientific notation is a way to write really large or really small numbers very easily to work with. Could you imagine having to add or to subtract or multiply or divide those numbers multiple times? So if you worked in like a lab where you're using microscopic parts, or you're dealing with exceptionally large numbers, I can't imagine maybe a bank that has, multiple dividends all across the world, instead of having to multiply those, they could very easily use scientific notation to deal with that. All right. So some things that you can look at, page 285. Starts out, it says, always estimate the answer before using a calculator. Good little tidbit there from Saxon, because that's telling you, is my answer in the ballpark, right? Scientific notation, it's showing you how to plug those in a calculator. Your calculator will write it in a format where it says E and then a number. So E means 10 to the, and then whatever number after it is your exponent. So that's an important way to understand what your calculator means. Now, one thing I want to point out to you, I am older than you guys, and a long time ago, calculators could not handle scientific notation. Now it can. So the needing to know how to convert and to do all that was a lot more significant when I was a student, because your calculator couldn't do that. Now calculators are so smart that you can plug in scientific notation to it and then press equals, and it will come out in scientific form. So that's an important thing. All right, so there are several pages, 286, 287, 288, and the top of page 289. Lots of practice with those. And it also talks to you about terminating and repeating decimals. We've talked about that before. Repeating meaning it never ends. All right, and again, your book reiterates in boldface, always estimate first to make sure your answer is in the ballpark. It says scientific calculators are programmed to find only roots or powers of real numbers that are real numbers. So that's why it's important to kind of estimate to know if you're in the ballpark. All right, it's not going to do the imaginary. Now, I had a calculator once that I could move it to that, and it would actually put I in there. But again, that's a different type of calculator. Okay, so let's look on page 289. It says use a calculator to simplify. Estimate first. So if you see practice A, and it says 0.00042 times 10 to the negative 17th over 568,425 times 10 to the 5th. All right, so when I'm looking at practice A, you guys will immediately notice from the start that it's not in proper scientific notation, because I should have a leading coefficient that's between 1 and 9. And I have 500 some thousand, right? So what I can do is rewrite them. So the first one, I'm going to have to move 1, 2, 3, 4 decimal places. So it'd be 4.2 times 10. And because I've had to take that and move it 4 decimal places, I'm going smaller to larger. So I'm going to have to go deeper in debt. So I already owed 17. I'm going to add, I'm going negative 4 more. So it'd be negative 21. So I've got 4.2 times 10 to the negative 21 is my numerator. Then I'm going to have to take my denominator. It was 568,000 and then 425. So I've got to move that 1, 2, 3, 4, 5. 5 places. So it would be 5.68425 times 10 to the, how many places did I move? 1, 2, 3, 4, 5. Now, because I'm going larger to smaller, I'm going to add 5. So now I can see that 4.2 and 5.6, if I were to estimate, the denominator is a little bit bigger than the numerator, but not much, right? They're pretty close to each other. And then I would just say negative 21 minus 10. So that's how I can estimate to see. Now I can actually plug this in my calculator. I could have plugged it this way in my calculator. Long ago, you could not do that. So you would be bound to follow scientific notation and then plug it. But now you can. So you can actually plug that into your graphing calculator or your scientific calculator, and you can actually get a very exact response, okay? So I know that 4.2 divided by 5.6842, you can plug that in your calculator and get your response there. All right, and I know it should be times 10. I owe 21, but then it's being divided by 10, so that means it's going to be minus 10. Because remember, the step behind division is subtraction. So it's going to be minus 31. So that is quite a large negative exponent because we're dividing. All right. So in estimating my response, I know it's going to be 0.9 or somewhere around there times 10 to the negative 31. So that's my estimated response there on lesson 68. Now, it also asks you to find the precise answer, so you will have to plug that into your graphing calculator or scientific calculator. So final answer that the book gives us, we knew that it was something times 10 to the negative 31. When we plugged it into the calculator, the final response is approximately rounded 7.39 times 10 to the negative 32. And that is extremely close. We knew that it had to be less than 1 whole since 5 is bigger than 4. And we knew just from the exponents that it had to be around negative 31. So final answer was negative 32. So great job, great job. But again, you can plug those into your graphing or scientific calculator. All right, now it asks you to use your calculator, and you're going to plug in the square root. Actually, it's the 4.2 root of 156. Now, friends, you're going to have to use a button on your calculator that looks like this. It's the x root. So what you would do is plug in 4.2 first, then x root, and then 156. Now, some of you, your graphing calculators will actually have like a box that you fill that in. But if you're using a standard scientific calculator, you have to type in what the root is first, press that button, and then press what goes under the radical symbol. And again, you're just going to round that to the nearest hundredth. All right. So if I'm to estimate, the 4.2 root is approximately the 4th root. Well, I know the square root of 144 is 12, and then the square root of 12 is between 3 and 4. So I'm going to estimate that it's somewhere between 3 and 4. When I plug it into my calculator, final answer, what did it say? Final answer was, I'm looking at, it's approximately 3.33. So we knew it was somewhere between 3 and 4. And I knew that because I knew the square root, and then I square rooted it again. And I knew that 12 fell between 9 and 16, which is the square root of 3 and the square root of 4. So great job. So your book is just reminding you to estimate and to do those. Let's look at practice C. All right, so practice A and B. We've done roots, and we've also done radicals. And again, all of these you can just plug in your graphing calculator. All right, so look at letter C, 0.00042 times 10 to the negative 17. And then you're multiplying that times 568,425. Oh, it's the same number. times 10 to the 5th. I thought, gosh, this sounds familiar. It's the same numbers, only they're asking you to multiply instead of divide. I'm sorry I had to stack them, that you're multiplying, not dividing. So what am I doing here? Well, I'm so sad that I just erased those, right? So it's 4.2 times 10 to the negative 21 times 5.68465 times 10 to the 10th. So this time I'm multiplying instead of dividing, so I'm going to add the exponents. So it should be 10, I'm estimating 10 to the negative 11. And I know that 4 times 5 is 20, so it's going to be around 20-ish times 10 to the negative 11 is my estimate, right? Our book said estimate first. Now, if I move that over, that'd be 2 times 10 to the negative 10th. So what's my exact answer? Well, calculator response is 2.39 times 10 to the negative 10. Woo, friends, my estimated answer was super close, wasn't it? And again, you can just plug this directly into your calculator. So lesson 69 is all about your scientific notation and also just using that calculator on those extremely large square roots. All right, on letter D, it's 1.86 raised to the negative 4.86. And I do want to remind you guys that you can just plug that into your graphing calculator. The negative exponent means it's going to be extremely small decimal because it's going to flip to the denominator. All right. Again, you can just plug that in. All right. Praise the Lord for wonderful, smart calculators. But you know, a calculator is only as smart as you tell it. So if you don't plug it in right, it doesn't come out right. So it is super important to be familiar with those and know how to use them. All right, lesson 69 is your gas law problems. So in lesson 57, we learned the gas law. And remember, that was PV over T. And pressure, volume, and temperature. Temperature was always in kelvins. And you'll do this a lot in chemistry class. So this is a good time for you to practice this. This is when I first started falling in love with high school science, was when I started realizing all the math that was in it. So I hope it'll be an encouragement to you. But a lot of times when you're using this equation, it's got a lot of scientific notation in it because it could have extremely large volumes or pressure, things like that. So they're taking two of the concepts we've already learned, the gas law and then scientific notation, and then they're merging them together to see how we can use those. Okay? All right. Only one practice problem in lesson 69. I know some of you all are devastated about that, only having to do one, right? So it says for us, let's read it. The quantity of an ideal gas has had initial pressure, volume, and temperature values of 50 times 10 to the third power atmospheres, 0.008 times 10 to the negative 4 centimeters cubed, and 300 times 10 to the 5th kelvins. Find the final temperature if the volume is 0.00005 times 10 to the 14th atmospheres, and the final volume was 0.00014 times 10 to the negative 8 centimeters cubed. Begin by solving the ideal gas law equation for T2, which means the final temperature, right? So how do I do that? Well, I set up my equation. You all remember that it's pressure of 1 times volume of 1 over temperature of 1 equals pressure of 2, volume of 2, temperature of 2. All right. So I've got my ideal gas law, right? Now, one thing your book did is you can also just cross multiply. So the pressure volume of the first times the temperature of the second equals the temperature of the first times the pressure and volume of the second, because we can cross multiply, right? So your book is just trying to point that out for you. And then your book actually solves for T2. So you can do that, or you can just set it up the way that you know. So that's all that your book is kind of showing you. P1 V1 times T2 equals T1 times P2 V2. Woo, there's a lot of letters in there, right? Well, if I'm solving for that, if I divide by P1 V1, I end up solving for the temperature, and that's what we're looking for, right? So your book just set it up that way. One thing you could do is just plug everything in and just solve it for the unknown. So either way, it will work out the same. But all that we have to do is plug in. My first temperature that they gave me was 300 times 10 to the 5th. And then that's being multiplied by 0.00, how many O's are there? 4 O's, 5 times 10 to the 14th. And then that's being divided by the pressure and volume of the first. So it would be 50 times 10 to the 3rd times 0.008 times 10 to the negative 4. All right. And so all that we have to do is combine those and solve. Now, I do want to remind you guys, your calculators are strong enough to handle all of that. Back when I was a student, it could not. So I would definitely have to plug those in. So you can convert everything. So I know that the first one would be 3 times 10 to the 7th times 1, 2, 3, 4, 5. I'm taking away 5 off of the second, so it'd be 5 times 10 to the 9th because I'm taking away. So you can easily see 5 times 3 is 15, and then 7 and 9, I'm adding together my exponents. So you all see how this can easily be solved just by working it out quickly using scientific notation. Or again, you can plug it in. Final answer, you just plug everything in the book and you're looking for the temperature of the second. So I'm going to let you guys finish that at home just because, again, it's easy. All right, so it's very simple of just plugging those in and to solve. So again, you're also dividing by the denominator. So your exponents, you're subtracting. When you multiply, step before add. When you're dividing, step before is subtract. All right, so that's all that lesson 69 is going over there. You've already learned the ideal gas log, but then you're plugging in a little bit more with the ideal gas log that they've used before were just simple numbers. Now they're plugging in your scientific notation with it as well. Okay, lesson 70. All right, big deep sigh. Advanced abstract equations. Now, last week we had advanced substitution, and it took us an extra video set aside because our board got so full, didn't it? So when we hear the word advanced, we go, but you guys understand that after Algebra 2, a lot of students take advanced math, so they're just preparing you guys. And I think Saxon does a great job of doing a lot of those advanced things with you so that you're more prepared. Now, taking a look at this, it says sometimes it's necessary to use the distributive property as the first step to solving a fractional equation. So sometimes you can distribute that and go ahead and set it up if you're trying to solve for something. So what they've done is they've given us an equation and they're asking us to find something in it, and it's a super large fraction. So if you look at your practice, it says mx equals p, and then z over x plus k plus 2s over y. Wow. All right, so here's my equation. You all can see why they're saying it's advanced. I don't see a lot of this on standardized test that it's this much information. Sometimes it's just a smaller part. But Saxon is one of those that they're never going to just give you the easy way out. They're going to make sure you know how to do that advanced thing. So I think you guys are certainly very well prepared. It asks you to solve for k. Well, the issue is k is all the way in a denominator. So how am I going to do that? Well, the first thing you're going to have to do is distribute the p so that you can get it on equal playing fields. So you're going to end up with mx equals pz over x plus k plus 2ps over y. So, all right, so one issue that you're going to have is I've got to distribute that to all of it. And that's super important in that what you need to do first is to get rid, you're isolating your focus. You need to constantly say to yourself, what is my focus? Well, my focus is to isolate that and to get it by itself, all right? So I've noticed that I've distributed the p. Now my goal is to get k by itself. Well, how do I do that? Well, I'm going to have to combine those two in order to isolate that k because I've got too many parts to it, right? That's going to make it a little bit more complicated. So very important. All right, and your book even showed you, if you're looking at, let me see what page the example is. If you're looking at page 294, your book kind of shows you that there, that it distributes it and then it solves it. So if you take a look, they did the exact same thing in example 70.2. So they distributed the m, and then what they had to do is combine it to get, it said to eliminate the denominators, we multiply everything by the LCM. And so they took care of that, and then they have this huge long problem. And then remember, the whole goal is to isolate the variable that they're trying to solve for. So that is a very, very large problem. So final answer is much bigger than anything you've ever had to solve for in Algebra 1. And I hope that that's not intimidating to you guys. It's just the reality of getting that variable by itself. So the first thing we did on this problem was we distributed the p so that everything was there. Now, your book actually shows that in order to get rid of all of what's in the denominator, you have to distribute. There are two different denominators. So I have to distribute x plus k and y to everything. So x plus k and y. All right. I am not going to be able to do all this on this little board, so we may have to, again, x plus k times y. All right. And I'm a little bit worried about distributing this where y'all can see it, but the whole goal is to get rid of those denominators. So x plus k and y. So I'm going to multiply all of that with mx at the very beginning. So what does that end up with? Well, you have mxy, and then that also gets multiplied with the x. So you get mx squared y plus, and then I have a k with that, so it'd be k m x y equals. All right, so all I did was distribute all of those. This is a binomial, and then m, x, and y are a monomial. So together I can put those and just distribute it to both parts, right? Now, the x plus k is going to cancel out the first part, but I've still got the y. So that's going to be p, y, z plus. Then the second part, the y's are going to cancel. So I'm going to have to distribute 2ps times x plus k. So 2ps would be 2psx plus 2kps. All right. So now what I've done is gotten rid of everything that is in a denominator, right? Now, keep reminding yourself, what is my final goal? Is to get k by itself. Isn't that what it told us? Find k. So I need to move all of the k's to one side. Everything that doesn't have a k moves to the other. So I'm going to underline everything that does let's underline everything that has a k. K and k. All right. So everything that has a k is here and here. So I need to move this to the other side, move this to the other side so that I can take out a k in common and divide through by what's with it. All right, so first thing, minus mx squared y minus mx squared y. And then I'm going to minus 2 kps. Minus 2 kps. All right, so I moved the things that have k to both sides, and I moved the thing that was with k to the opposite side. So I'm going to write it together. K mx y minus 2 kps equals pyz plus 2psx minus mx squared y. Wow! All right. Praise the Lord, I haven't run out of boardroom yet, right? But you all see how important it is to be careful with your signs and distribute carefully. Now, all I'm going to do is take out the k in common and show what's left. mxy minus 2ps. All right? So I took out a k from the first, and this is what's left. That's what I'm going to divide both sides by. mxy minus 2ps. mxy minus 2ps. So what that's going to do is going to cancel here. So what does k equal, my friends? K by itself is all of this divided by this. All right, it is massive. And I do want to encourage you, you are welcome to press pause and look over it, watch your signs. I do notice that in the book answer key, I'm really big on making sure the order is right. They have x squared somewhere different, but I just make sure the order is there. So the final goal is I'm getting that one variable by itself. So get everything that has that one variable. I got all of my k's on one side, and then everything that didn't have a k on the other, and divide through by it. All right. Did I mention that it's called advanced for a reason? No stress, right? All right, so that was lesson 70. All right, and then lesson 71, you as Algebra 2 know that I love the quadratic formula. In fact, you guys just had an assessment where I asked you what the quadratic formula was. So I don't think any of these are going to be any particular difficulty for you, because we've been using the quadratic formula when it's not set up to easily use the completing the square, right? So letter A says begin with ax squared plus bx plus c and derive the quadratic formula. Well, I hope at home that you guys remember that memorizing that quadratic formula is super important. And I hope you can say it along with me. Negative b plus or minus the square root of b squared minus 4ac over 2a. So knowing that quadratic formula is super important. That's going to help you later on when you're solving those. Now it says use the quadratic formula to solve. What is the question that they're asking us? Well, it's 2x squared minus 6x plus 4 equals 0. One thing I want to point out to you is be on the lookout. Sometimes it's not in the right order. Sometimes it has something on one side of the equal sign and not the other. So be careful. This one is in the correct order. So I can just write underneath it, write A equals 2, B equals negative 6, C equals 4. So I can solve it. Negative 6. Negative 6. Where did I get that? Where it was negative B. B was already negative. So it's negative 6 becomes positive 6. Plus or minus the square root of negative 6 squared. And I want to remind you, put that in parentheses, because it's saying the whole thing of b is squared. So that's going to become positive 36. Minus 4 times 2 times 4 over 2 times a, which is 2. So it's 6 positive 6 plus or minus the square root of 36 minus 4 times 2 is 8. 8 times 4 is 32 over 4. So it's 6 plus or minus the square root of 4 over 4. Well, square root of 4 is 2, so it's 6 plus or minus 2 over 4. All right, so I can actually solve this one, and it is a real number since it's a perfect square root. So 6 plus 2 is 8. 8 divided by 4 is 2. So my answer is 2, and my answer is also 6 minus 2 is 4. 4 over 4 is 1. So I have two different answers. My answers would be 2 and 1. So very easily for me to solve using the quadratic formula. Now that means that I could have actually factored it probably. So that's pretty interesting. I didn't even think through, can I factor this? But remember, there's always multiple ways that you can set that up and solve, okay? That is all of your work for this week. So there are 4 lessons. Coming lessons we will start when we come back, but I would encourage you that we'll keep plugging away. Lesson 72 is about lines with experimental data and negative angles, and setting those up. And then also they're showing some negative angles with vectors, like with your angles, thinking through how to set those up. All right, so going the opposite direction of what we have been. All right, great job on these 4 lessons.